Hello student, this is your physics teacher Mr. Anup Shah from Kolkata. Today we are going to start a topic thermal expansion of solid. Okay? Uh, Thermal means that it is related to the heat, and whenever we are providing heat to any substance, let us suppose here this is known as the substance A. Now when we are providing the heat to it, we are finding that its volume increases. So we are going to study how actually the expansion happens. Expansion can be of three types. Expansion can be of three types. Expansion can be of three types. Linear expansion, so linear expansion, superficial expansion, and sometimes in a more common language it is called area expansion, and the third one is known as volume expansion. Volume expansion. So linear expansion, let us suppose there is a rod, and when we are trying to provide some heat to it, what will happen? The length increases from L1 to L2. Now the rod becomes more longer. Similarly, area expansion, let us suppose there is a square plate, okay, and you are providing heat to it. What will happen? It will become somewhat bigger. Yes, if you are providing heat in a uniform way, so in that case the heat will be distributed throughout, and in that case the shape of the substance will also be a square. Okay, so the shape is not going to change. It will be a square initially, and it was a square initially, and after the heating it is square too. Now volume expansion, let us suppose that there is a cube, and you are providing heat to it, so it will become somewhat bigger. Somewhat bigger, and the shape will be same, that is it will be cubical. So these are the expansion: linear expansion, area expansion, and volume expansion. Right now we will study about the linear expansion. So let us linear expansion. Linear expansion of solid. So there is a rod. Let us suppose this is the rod, and it has a length L1 at T1 degrees Celsius. Now it is provided some heat. Uh, so we are finding that the length increases. The length increases. Now the length becomes L2. Now the length becomes L2 at T2 degrees Celsius. Sorry, T2 degrees Celsius. So of course here T2 is greater than T1, and we all know that the length will increase, so of course L2 will also be greater than L1. Now there will be change in the length. The change in length is will be equal to L2 minus L1. Change in length will be equal to L2 minus L1. Okay, this is a change in length. Now here we are finding that this change in length is proportional to change in temperature as well as its original length, that is before heating. So it is also proportional to original length, it is also proportional to the change in temperature. So when we are actually combining it, we will find that L2 minus L1 is proportional to L1, and L2 minus L1 is proportional to let us suppose the change in temperature is T2 minus T1. Okay, not it is supposed to be theta, let us suppose, and here L1 is supposed to be, let us L. Okay, so this L2 minus L1 I am replacing it by DL. So DL is proportional to length and DL is proportional to theta. Combine it. On combining, we will find that DL is proportional to L as well as theta, where theta is the change in temperature. Now, if I remove this variation sign, a constant will come. A simple mistake, one mistake happened. This will be equal to DL. DL is proportional to L and theta. So on removing this proportional sign, I will get DL is equal to L theta and one constant, and that constant here it is alpha. So this is the proportion sign and this is the alpha. Now alpha has actually known as coefficient of linear expansion. So alpha can be written as alpha is equal to dl L theta. So it can be defined as increase in length per unit length, because we have to keep the denominator unity. So simply let us this one. This one. The denominator should be kept unity, and for that purpose we have assumed that original length is unity per unit length per unit rise in temperature, per unit rise in temperature. So this is the statement of the alpha. So alpha, what could be the SI unit of alpha? So they see here, this is the initially in the numerator it is the length and denominator is also the length. So length will cancel out, only the temperature will remain. So the unit will be either per degree Celsius or per Kelvin. Okay, so we should write per Kelvin because Kelvin is the SI unit of the temperature. Okay, degree Celsius, it is the unit in the Celsius system. Thank you.